Hi, welcome back to Lecture 9. We'll discuss evolutionary change in a bit more detail. Assuming that phenotypic differences are genetically determined, favoring individuals with certain phenotypic traits should lead to evolutionary change, and it has. Geneticists have imposed selection on several aspects of Drosophila melanasta, e.g. body size, eye color, growth rate, and lifespan, with a consistent result. Evolutionary response results from selection for a trait. Having selected fruit flies with many bristles on their abdomens, each generation, scientists picked out the 20% of the population with the greatest number. At the start of the experiment, the average number of bristles was 9.5. After 86 generations of this directional selection, the average number of bristles had quadrupled. An experiment with corn demonstrates the ability of artificial selection to rapidly produce major change in crop plants. In 1896, agricultural scientists began selecting for the oil content of corn kernels, which initially was only 4.5%. Just as in the fruit fly experiments, the top 20% of the population were allowed to reproduce. By 1986, at which time 90 generations had passed, average oil content of the corn kernels had increased approximately 450%. Artificial selection imposed on dogs has produced a great variety of breeds. In some cases, breeds have been developed for particular purposes. Greyhound dogs, for example, resulted from selection for maximal running ability, resulting in an animal with long legs, a long tail for balance, an arched back for increased stride length, and great muscle mass. Bootstrapping is a computational technique for estimating a statistics for which the underlying distribution is unknown. A resampling technique that estimates sampling distributions by repeatedly sampling data from the original data set and is used as a means to estimate confidence levels of clades within a phylogenetic tree. The bootstrapping values indicate how many times out of 100 the same branch was observed when repeating the phylogenetic reconstruction of a sampled set of data. If one gets 100 out of 100, one can be fairly certain that the observed branch is not due to a single extreme data point. If one gets 50 out of 100, one cannot be so certain. Branches show the path of transmission of genetic information from one generation to the next. Branch lengths indicate genetic change, i.e., the longer the branch, the more genetic change or divergence has occurred. Unintentional selection has also resulted from domestication. As part of an attempt to domesticate the silver fox, Russian scientists over a period of time chose the most docile animals in each generation and allowed them to reproduce. After 4 decades of selectively breeding the tamest individuals, most foxes were exceptionally tame, sniffing and licking their caretakers and allowing themselves to be stroked. Essentially, they had become like domesticated dogs. If selection operating over a period of only 10,000 years, since wolves were first domesticated, can produce such substantial differences, it should be powerful enough over the course of many millions of years to produce the diversity of life we see around us today. In artificial selection, plants or animals are mated in an attempt to conserve desirable traits. Rapid and substantial results can be obtained over a noticeably short time, often in a few generations. From this, we can see that evolutionary change can come about by means of natural selection. I hope you enjoyed that lecture on evolution. We continue once more. I'll elaborate more on evolution in the next lecture. Thank you.